when we are solving multi-step equations, that's what we're doing for today. Okay, that's our learning target. Our learning target is we can solve linear equations with multiple steps using distributive property and combining like terms. You are incorporating what our previous unit was, what you guys just did for your expressions unit. You're taking that information and you're combining it with solving. So when you were doing your expressions unit, you were simplifying your expressions so that it was down to just two terms. You had a variable term that had a coefficient, whether it was a visible coefficient or not, and you simplified down to a constant, something that was a number that was added or subtracted with that variable term. That's what you are doing here. You are simplifying expressions first before you get into the solve part. The whole goal is to simplify this long drawn out expression that we see on the left side and on the right side so that it's down to a two-step equation. That's the purpose, that's the goal. Okay, so it's the same process of what we were doing with the expressions. The very first thing that you have to do when solving for a long drawn out equation, you gotta distribute. Distribution is always that first process that we do. And remember, we know that there's distributive property if we see an expression inside of parentheses. So right here, we see an expression that's inside parentheses. That means I need to distribute. What value is getting distributed though, Fatima? -4. Okay, that -4 acts like a -4. It's getting multiplied to the 3x and to the -6. So remember, those are our terms that we are splitting up. Okay, so things that did not change. The 9x did not change at all. It still stays a 9x. When I distribute, I am focusing on doing -4 times 3x, which is going to give me what? What's -4 times 3x, guys? -12x. Then we're distributing -4 times -6. -4 times -6 is going to give us what? 24, positive 24. So I have to put that plus sign to indicate that it's positive. It's a positive 24. Okay? Everything else is going to come straight down. Nothing else was affected by that distributive property. So we still have equals -3 plus 18. Okay, now with an equation, you have sides. You have a left side and you have a right side. That equal sign essentially is creating the wall to your left side and to your right side. You have to simplify both sides first. Okay, you have to do what it tells you to do. I know everybody thinks, oh, but it's an equation, you have to do inverse operations always. You don't do inverse operations until you're ready to solve. Right now, we're not solving. We are just simplifying. That's all we're doing. We're not solving anything yet. It's just simplifying. Do you have a question or just, okay. All right, so we're going to combine the like terms that are on the left side of the equation if possible. Sometimes it might not have anything to simplify. But right now, we do have stuff that can be simplified. What can we combine together here? What like terms do we have here? Amy? No, not Amy. Oh my God. I'm so sorry. Asia. 9x and the -12x. I knew when I moved you guys to different seats I was going to lose the names. All right, so 9x and that -12x. That 9x and that -12x can be combined together. When we do 9x minus the 12x, that's going to give us a -3x. Is there anything else on the left side that can be combined? Yes or no? No. Okay, so that means everything else comes straight down as it is. Plus the 24 equals, and then we've got negative 3 plus the 18. That's as simplified as that left side is going to get. Now, step 3, we focus on simplifying like terms on the right side, if possible. So now I'm looking on my right side. Can I simplify the right side? Yeah, I can simplify the right side. The right side has 2 constants. The right side has 2 constants, so I can simplify that. What is negative 3 plus 18 going to give us? Positive 15. I don't have to write the plus sign here because I don't have anything else on that side. So I have a positive 15 is equal to, and then everything else comes down. So we have negative 3x plus the 24 is equal to 15. We have simplified our expression completely, so now we have a 2-step equation. That's it. Multi-step equations just means you're simplifying until it's a 2-step equation. Once you have it as a 2-step equation, then you can start doing your inverse operations to solve. Okay? So let's go ahead and solve it. We're going to identify our constant first, and we're going to either add or subtract it to both sides. So we had that negative 3x plus the 24 is equal to 15. What number is my constant? Amy. 24. Positive 24 is my constant. What is the inverse operation for here? Leah, what's the inverse operation going to be? What's the inverse operation going to be? Minus the 24. So we're going to subtract 24 from both sides of the equation. That means that the 24s are now going to get boxed and canceled off. And we are still left with negative 3x, but it now is set equal to what? What's 15 minus 24, Mario? Negative 9. Okay, from there, we can now take this 1-step equation and we solve by either multiplying or dividing on both sides, depending on what operation we see right now. What operation is it when they're side by side, Logan? Multiplication. So what's the inverse? Division. So we're going to divide both sides here by what value? Negative 3. You have to make sure when you are multiplying or dividing, you have to include the sign. If it's addition or subtraction, you're doing your opposite of the sign. Unless it's a double sign. If it's plus a negative, then you're subtracting a negative. If it says minus a negative, then you're adding a negative. The only time that you would do opposite of the sign is if it just says minus this number or plus this number, then you would do the opposite for that. Okay? Here we're going to go ahead and simplify that coefficient down to just a single value of x. And then negative 9 divided by negative 3 is positive 3. When you are working these problems out, you will want to work it out on paper. You do not want to look at these and try to do it all in your head. You are going to want to use paper so that you can map your process out, especially when we start throwing in those fractional coefficients. Okay? You want to make sure that you are working these things out on paper. I've been doing this for years, and I even work my stuff out on paper. I may be able to do a lot of it all at once, but I still write stuff down. My steps are a little bit more squished. I can limit myself. I don't have to break it down into, oh, simplify my left and then simplify my right. I can do quite a bit of that all on my own. I can even do 2 steps in my head. But when I've got these multiple steps where I'm having to distribute and I'm having to combine like terms and I'm having to maybe have variables on both sides, which we're going to do that on Monday, you're going to need to write stuff down. If you hand me your assignment and say, I did it all in my head, I'm going to say, do it all on paper and then turn it in. Okay? All right. So let's take a look at these two problems. We're going to do these two problems together. Then you're going to do the back side on your own. Actually, you'll do the back side with a partner. You'll do the back side with a partner. Your assignment you'll do on your own. Okay? So let's take a look here. For problem number 1, what's the first thing that I always should look for? Before I begin, the first thing I always should look for, Mario? First thing I should always look for, even if it's not there, I should always check to see if it is there or not. To see if you can distribute. That's always the very first thing we want to check to see if we can. Distribute if possible. Do we have distributive property? No. That's when you go to your second. Think of it like a checklist, guys. Okay, look for distribution. I don't have any distribution. All right, look for combining like terms. Can I combine like terms? Yes. On the left side, I can combine my like terms. I can do 4n minus 2n. What is 4n minus the 2n? 2n. So we have 2n. Can I simplify anything or combine any like terms on the right side? No, it's just going to stay a positive 4. So now we have a single step equation. Very, very easy. 2n is equal to 4. What is the inverse operation that I am going to do here? Kai. Division. We are going to divide both sides by 2. And that'll give us n is equal to 2. And guys, if they ever have you dividing both sides by a larger number, okay, let me show you what I mean. I'm going to write this up to the top. I'm just going to scoot up for a second. Let's say that they give you something like 8x is equal to 5, and they want you to solve that. And you're like, okay, I have to divide by 8, and I'm going to divide by 8 on the other side. You can still do that, and you can leave your answer as a fraction. Remember, division is just a fraction bar, guys. You can leave your answer as 5 over 8. That is a fraction answer. It's perfectly fine. I had some of you coming up yesterday and going, I don't know what I'm supposed to do because if I divide, it's not going to divide nicely. It's not going to be a perfect number. Then leave it as a fraction. If it's delta math, you can leave it as an improper fraction. Or you can convert it to a decimal. It doesn't matter. If it doesn't convert nicely as a decimal, though, I would leave it as a fraction. Okay? Fraction answers are great, especially when we get into our functions unit. You're going to need to leave your answers in fraction form, both proper and improper, because we'll be utilizing those as a sloped method. Okay? All right, let's take a look at problem number 2. First thing that we always want to check for is, again, what? Everybody should be saying it. Distributive property. Do we have any distributive property here? No. Second thing I check for is, can I combine any like terms? Let's focus on the left side. Can I combine anything on the left? Nope. All right. Let's focus on the right side. Can I combine anything on the right? Yes. I can combine this positive 5v and this positive 2v. When I combine those together, I get a positive 7v. Nothing else can be simplified, so the rest of my problem remains as is. Negative 12 is equal to 2 plus 7v. Okay, now I've had students in the past who say, I don't like having it written this way. I don't like it when it's written with the variable on the right side. I 100% agree with you, because especially when we get into inequalities, you're going to have to always have your variable on the left side for graphical purposes. So if you would like to do a rewrite of it, I am perfectly fine with that. In fact, I'm even going to say, rewrite. All that means is that you're going to take 2 plus 7v, put it on the left side of the equal sign, put negative 12 on the right side. I didn't change any signs. I didn't change any order within each specific expression. I just flip-flopped the two sides. That's it. Everybody clear? If you're fine with leaving it as is and solving, that's perfectly fine. But when we get into inequalities, you're going to want to do that rewrite. And we're getting into inequalities in about a week and a half. All right, so let's take a look here. What's the first inverse operation that I am going to perform? Hassan? And what are we subtracting? Okay, so I'm going to subtract the 2. Is it because of this plus sign that's causing me to subtract? No. No. That plus sign belongs to who? The 7v. Plus sign belongs to 7v. So it's not that plus sign that's causing us to subtract. It's because the 2 was positive. There's technically a little invisible plus sign right in front of that 2. So we're going to subtract 2 from both sides. And then I'm going to box that off. Okay, I'm still left with a positive 7v. So I don't have to write the positive sign. I can just write 7v. And then negative 12 minus the 2 comes out to a negative 14. From here, last step, what are we going to do now, Richard? Good. We're going to divide, and don't just say I'm dividing negative 14 by 7, because that's not the only thing that you're dividing. You're dividing both sides. In equations, everything happens to both sides when you are solving. The reason it has to happen to both sides is because that's how you maintain balance. So we're dividing both sides by the 7, and we now have v isolated. V is going to be equal to negative 2. And I'll zoom in on that so that you guys can see that a little bit better. Okay? All right. So, I'm going to give you a little autonomy here. You can partner up with somebody if you wish to partner up with someone, and you're going to do those next set of questions together. I'm going to give you about 10 minutes. 10 minutes to complete them. Make sure that you are discussing it. You're not just copying somebody, but you're actually having valid discussions about what your processes are. Checklist. Make sure you're going through everything and checking it off together. If you want, one of the great things to do, sometimes you work it out separately and then you check with each other. Hey, did you get this answer? Oh, you got something different? Well, let's see what we did wrong. Okay? But you've got 10 minutes. Get with a partner. If you don't want to partner with somebody, that is your choice. Okay? But go. Problem number 3, you should have gotten x is equal to 0. The first thing you want to do is combine your like terms of the x and minus 5x. That gives you that negative 4x. And then that positive 3 still comes down. It has nothing to combine with it. Again, like I mentioned, you might want to rewrite. That means I'd have negative 4x plus 3 is equal to 3. I would subtract 3 from both sides, and then I would get 0. And I had a lot of you going, wait, hold on, but what do you do now that it's a 0? You still treat it like a number. 0 is a number, guys. If you take 0 and divide it by negative 4, you still get 0. So x is equal to 0. For problem number 4, we have x plus 3 minus 3 is equal to negative 6. That plus 3 and that minus 3 can be combined together to give you a 0. You don't have to have that 0 there. You don't have to add or subtract or do anything with the 0 because it doesn't matter what you do. It's still going to equal the same value on the other side. So you're just left with x is equal to negative 6. So you can cancel out that 0. Okay? Let's take a look at problems 5 and 6. Problems 5 and 6, you had distributive property that needed to be completed first. For problem 5, you distribute the negative 3 to both terms, and that would give you negative 3x minus 6. I would then rewrite it so that the negative 3x minus 6 is on the left side of the equation. The positive 6 is on the right side. I then would add 6 to both sides. When I add 6 to both sides, I cancel these 6's out, and that 6 becomes a 12. You now have negative 3x is equal to 12. You would divide both sides by negative 3 and get x is equal to negative 4. For problem number 6, distribute the negative 3 to both terms first. Don't forget that that 8 is a negative because it has a minus sign in front of it. Whenever I see that minus sign, I like to circle the term so that way I remember it's a negative. Okay, so negative 3 times 4x is equal to negative 12x. Negative 3 times negative 8 equals positive 24. And the whole thing is set equal to negative 36. You then would subtract 24 from both sides, and that gives you a negative 60. When you divide both sides by negative 12, you get positive 5. Okay, and this is going to get posted. Don't forget that these do get posted onto Google Classroom. I'll have these notes showing up later. I just want to go through them because some people are already done and ready to progress on to the next step. Okay, number 7. You're going to distribute the 1/4 to both terms. 1/4 times 5x gives you 5/4 x. 1/4 times negative 8 gives you a negative 2. If I rewrite, I now have 5/4 x minus 2 is equal to 8. I'm then going to add 2 to both sides. That gives me 5/4 x is equal to 10. I would then divide both sides by 5/4 and get x is equal to 8. For problem number 8, this is probably our lengthiest one, we had to distribute the 3 to both components, both terms on the inside. 3 times 4x gives me 12x. 3 times that -5 gives me a -15. That minus 4x and plus 1 still comes straight down, so does the equals -6. I then combine like terms. I've got multiple sets of like terms to combine on the left side, though. I have variable terms, 12x minus 4x. I also have constant terms, -15 and a +1. Okay, do not forget to combine all your like terms. If you drop a term because you forgot to combine it, it's going to change your answer, right, Richard? Yeah. Okay, so 12x minus the 4x gives you 8x. -15 plus the 1 gives you a -14. You then would add 14 to both sides, gives you 8x is equal to 8. You would divide both sides by the 8 and get x is equal to 1. Okay, these are going to be left up here. I'm going to leave problem 7 and 8 up first, and then I'll scroll back to problems 5 and 6. I think you guys are pretty okay with 3 and 4. You have a mystery picture assignment loaded on Google Classroom. That needs to be completed. I am going to pass out to you this grid paper for you to show your work for the problems. It's 12 problems. You are showing your work on this grid paper and turning this in when you turn in the mystery picture. Is that understood? Okay.